Hi, and welcome to Simultaneous Equations Video 2. I'm going to talk to you about the first of three methods that you'll be learning regarding solving simultaneous equations. So last video we talked about the difference between a relationship, an equation, a function, and a formula. In this lesson I'm going to talk to you about how to solve simultaneous equations. But you'll notice here that within my example I have some terms, I have variables x and y, I have an equal sign, so there is definitely a relationship there. But I have two variables in the first equation and two variables in the second equation, which means independently they aren't solvable. The nice thing is though, together there is one specific solution, and we're going to find that specific solution. So while the relationship between x and y in equation 1 gives you a whole set of different solutions. For every x value, there's a specific y value that makes the whole thing work. And there are an infinite number of these. There are lots of whole number solutions. There's lots of decimal and fractional solutions as well. Some negative, some positive, so on and so forth. And the second one gives a whole set of solutions again. But there is only one solution that works for both at the same time. Or you might say that works for both simultaneously. And that's what we're talking about, simultaneous equations. So the first thing you'll need to do to solve them graphically is to graph them. So in the past you will have dealt with some linear function plotting. You will have talked about gradients, or M, and you will have talked about rearranging the equations to get y equals mx plus c, y-intercepts, maybe x-intercepts, and different methods for plotting those functions. If you plot both of those functions on one graph, you'll get something that looks like this. There's my two functions. Now you'll notice here that I have used a website called desmos.com to plot these two functions. I would like to reference that, but the main reason I want to reference that is that's a really good website that you could use. Now the blue line represents every possible pair of x and y coordinates that work for that relationship. So for example, x equals 2, y equals 2 will work in this relationship. 2 minus 6 gives negative 4. Or x equals 1, y equals negative 1 works. And the same with the red line. X equals 0 and y equals 7. Whilst we have that situation, there is only one specific point that will solve both of them at the same time. And here it is. X equals 3, y equals 5. Or as a coordinate, 3, 5. So we have the coordinate 3, 5. And that solves both equations. And that is our solution to this set of simultaneous equations graphically. I have another example down here. And this example does not come out quite as nice. So what I'm going to do is I'm going to show you how to use Desmos for this particular example. 2k minus j equals 4. In Desmos, I'll write that as 2x minus y equals 4. Desmos recognizes the two variables x and y. And my second, 4j plus k equals 13, I have my y set as j and my x set as k. So I've got 4y plus x equals 13. The two simultaneous equations have been put together onto one set of axes. But unfortunately, the solution here is not quite as clear as the solution before. If you're using Desmos, you can simply hover over that, click on it, and it will give you the solution, 3.22 and 2.44. And there it is, 3.22 and 2.44 on my graphical solution of these two simultaneous equations. From this lesson, I hope you've understood that to solve systems of linear equations, you need to first plot the linear equations and then find the center. And that is your graphical solution. So if you're asked to find a graphical solution, this is what you should be doing. Thanks for joining me. See you next lesson.